All right, page 2 of the study guide. So it says find the zeros of each function, state the multiplicity, and tell whether the graph touches or crosses the x-axis at each zero. So I give you this chart. Now, if there are not 3 zeros, then you're not going to use all the columns. If there's 4 zeros, you'd have to add a column. So sorry about that. That's just a risk we take. So finding the zeros. Well, right here you have an x, right? So that is a 0. X could be 0. It'd make the whole thing 0. So that makes it a 0. Then this is a factor, x plus 3. So think about what makes that factor 0. -3. And if you have trouble with that, just go x plus 3 equals 0. You're setting each factor to 0 and then subtract 3. And you're going to get x equals -3. Okay, I have a little space. Okay, and then set this factor to 0. Same thing, and you're going to get 7. All right, those are the zeros. There were 3 of them. There they are. What's the multiplicity? Okay, you're looking for the exponents. So for that first factor that when had a 0 of 0, the multiplicity was 1. This one, it's 4. And on the 7, it's 5. So the chart just keeps you from having to write a bunch of words out, and it keeps it all organized so I can read your answer. Okay, does it touch or cross? If the multiplicity is even, then it touches or bounces. If you want to put bounce, then I'll know you watched the video. Okay. If it's odd, if the multiplicity is an odd number, then it crosses. And that's all we're doing, touches or crosses. Okay, so 1, so on this one, 1 is an odd number, so it crosses. 4 is an even number, so it touches or bounces. And 5 is an odd number, so it crosses. So a lot to remember, but not too bad. You just make your note page. Okay. Divide using synthetic division. Okay, so how do we do that? You look for what makes that 0. So it's written x minus c. So c is 2. So you put 2 in the box. And sometimes students like to think, oh, it's the opposite of -2. Okay, that's fine. Then you're going to pull off these coefficients. You need to make sure that the polynomial you're dividing into, the dividend, that it's in order from highest degree to lowest degree, and that there are no missing terms. This one doesn't have any missing terms, so this is just checking to see really if we know what synthetic division is and how to write the answer. Okay, so we pull off the coefficients, 5, -6, 3, 11. Be careful with the signs. If it's negative, you got to make it negative. All right, you always bring down the first number, 5. And you multiply, 5 times 2 is 10. And you add, -6 and 10 is 4. Then you multiply, you get 8. 3 and 8 is 11. And then you multiply. My arrows are going to make a mess, but that's 22. And then you add, 33. I always put a box around the last one because that's your remainder. Okay, this is not the answer. This is the synthetic division part. The answer just says these are the coefficients. And where do you start? 1 degree down. So it used to be a 3rd degree. Your dividend was x to the 3rd. So you're going to go x squared. So 5x squared plus 4x plus 11. They were all positive, so that's why it's plus. Plus, and then you have to put the remainder, which is 33, and you're going to put it over the divisor, which is x minus 2. And that's the answer. It's the quotient. Wow. Okay, so hopefully you're loving synthetic division because it's a lot of fun. But that question is just seeing if you know how to do synthetic division, basically. Okay, now we use synthetic division a lot, though, in this chapter. So it says, this one's kind of wordy, so it's not as bad as it looks. Solve the equation. So you're trying to find the zeros of that equation. You're trying to find when does that polynomial equal 0. But it tells you that -2 is a 0 of the function. Well, notice that this is the same polynomial. Okay, so if it's a 0 of the function, then it's a 0 of the equation. It's a solution when you have it set to 0. Okay, so we're going to divide by -2. -2 goes in the box. We do this synthetically. Again, we're pulling off those coefficients. make sure it's all in order and your signs and there's no missing terms. Okay, it's all good. Okay, so the first number comes down to 2 times -2 is -4. -3 and -4 is -7. -7 and -2 times -7 times -2 is 14. -11 plus 14 is 3. And 3 times -2 is -6. 6 and -6 is 0. Now, we knew it was a 0. So if it didn't come out to be a 0, then we did our synthetic division wrong. But it did. Yay. Okay, so we got that right. Now, what that means is, it means x plus 2 is a factor, but we don't even care about that. Because they're not asking us to factor it. They just want us to solve this equation. Well, now we have this 2x squared minus 7x plus 3. So we know x plus 2 is a factor. We know -2 makes that true. But now we have this left, this whole thing here left. And we want to know, when does that equal 0? Now, this is quadratic. You can use a quadratic formula. You can use factoring. I'm going to factor because it factors 2x minus 1 and x minus 3. Now, I've done a lot of factoring in my day, so for me it's just easier to factor, but you could use the quadratic formula as well. The AC method works on this. You find two numbers that multiply to be 6 and add to be -7. Those are going to be -1 and -6. And then you go through the AC process. Let me do that really quick just so you can see how to factor it if you want to do it that way. If you're like, oh, I don't remember how to do that. Oh, shoot. Why did it do that? I must have hit something. Hit the edge or something. That's a 0 there. Okay, anyway. So you factor out an x, you get 2x minus 1. And here you factor out a -3. You're factoring out the GCF, and you get 2x minus 1. In order for the AC method to work, that parenthesis has to be the same as that, and it is. And you're going to get 2x minus 1 times x minus 3. And that's just a review of factoring. Okay, so when does this equal 0? Well, you can just write it out. 2x minus 1 equals 0, which means 2x equals 1 and x equals 1/2. And the other one, you can do the same thing. You're going to get x equals 3. Okay, now when you put the answers, it says to solve the equation. You need to put then x equals, and you can just write them out, or you can do set notation. That would be fine. But don't forget to use the one that you already knew. -2, 1/2, and 3. So there are 3 answers there. You can either write it like that, or you can write it in set notation. Okay, that's kind of a long problem. List all possible rational zeros. This is the rational zeros theorem, okay? It's P and Q. You take the factors of P and you put them over the factors of Q. This one's P, it's at the end, and this one's Q, it's at the beginning. That's just the way it is. All right, what are the factors of P? What are the factors of 6? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. What are the factors of 1? That's like a 1 there. Plus or minus 1. Now, technically what you're doing, because you might get a different problem, you're doing P over Q. And they're all plus or minus, but you have 1 over 1, 2 over 1, 3 over 1, 6 over 1. Sometimes Q has more than one factor, so like it might have like a 7 or something. So you do all of them over 1, and then you do all of them over 7. But this time it just has the 1 factor. Anyway, so that's just going to mean that these are all 1, 2, 3, and 6 when you simplify, and they're all plus or minus. Could be positive or negative. Okay, so those are the possible rational zeros. Those are the only rational numbers that will work work as a 0 for that equation. They're the only possible ones. They aren't all going to be zeros, but they could, one of them could be a 0. Okay, so that's page 2. We're going to use this answer at the beginning of the next page.